Hi everyone. In this video we are going to learn how to convert between standard form and vertex form for quadratic equations. So here are the two forms. On the left we have standard form and on the right we have vertex form. So we're actually going to start by going this direction. Let's learn how to convert vertex form into standard form. All right. We're going to use order of operations to do this. So first I'm going to work with the exponent and multiply x minus h times x minus h. Alright, so this becomes a times x minus h times x minus h plus k. Alright, so I'll still have an a, and then I'm going to use FOIL first. So I'll do the first terms multiplied, x times x is x squared. Outer terms, x times negative h is negative hx. And I'm going to write the x second, and then the h would normally be a number, so I'm going to write that first. That's the coefficient. Middle terms, right, or inner terms, negative h times positive x again, another negative hx, and then last terms, negative h times negative h is positive h squared. So whatever that was, even if it was a number like 3 times 3, 5 times 5, h times h, that's all going to be just the square of whatever that number is. All right, and then I still have this plus k. So, combining like terms. I actually do have two like terms, the ones with x's, and I need to add the coefficients. So, negative h minus h. Now I can work with that just like an algebraic variable. So this turns out to be negative 2h. Alright, so I end up with x squared minus 2hx, so that term still has an x, plus h squared, and then plus k. Okay, so we're using order of operations. I've worked out the exponent. Next I want to multiply, so I'll do a times all of these terms. So that becomes ax squared minus 2ah, and we usually do numbers first, okay, then letters that represent numbers, and then x, plus ah squared plus k. And that's about as much as I can do to simplify this. Alright, so this is vertex form, and I've switched it to, this is standard form now. Alright, so let's try to pick out a, b, and c. Well, a in standard form is whatever's in front of x squared, so that's still an a. Now for b, I have this minus 2h in front of the x. And then for c, I have this whole term at the end. It's actually two terms, right? But taken together, all of that would be considered the c. All right, it's a constant. Those would all be numbers. So order of operations, I could work all of those out, and there's no x in that term. So for example, like if a was 2 and h was 3, and then k is another number like 1, alright, then I would get 2 times 9 plus 1, or 18 plus 1, or 19. So I can simplify that and eventually end up with just a single number. Alright, so what would be nice now is if we had some formulas to go directly from one form to the other. Alright, so notice to get from ax squared plus bx plus c to vertex form, it's not really apparent what I can do to figure that out. So in the other one, going the other direction, alright, you might have picked up on the fact that you could use order of operations and do that multiplying to get this into standard form. But to go backwards, that's a little bit harder. So what we're going to do is set up some equations, and basically I just want to put an equal sign between a, b, and c, and these new things that equal a, b, and c. Alright, so first of all, I know that the A in vertex form is the same as the A in standard form, and that's why we use the same letter. Right? So that doesn't really tell me anything, other than just, A still represents A. However, for B, this is a helpful relationship. I know that B in standard form is the same thing as negative 2h in vertex form. Right? So what that does is it gives me a way to convert back and forth between B and negative 2h. And we'll look at some examples in a minute so you can see how this works. Right? Now usually we write this in a different form. We usually divide by 2, right, and a negative sign. So we rewrite this as negative b over 2 equals h. And that's the way you'll typically see that formula written. But same idea, we can still convert back and forth between b and h. Okay, and then finally c. Alright, since all of this equals c, then I have c equals, and you usually see this written, for some reason, reversed, k plus ah squared. It doesn't really matter though, so I'll leave that one alone. Ah squared plus k. Alright, so in other words, if I had vertex form, if I knew A, H, and K, then it would be possible to use these formulas to work backwards and use A, H, and K to figure out B and C. So here's a quick summary of what you need to do to convert back and forth. If you're going this direction, switching from standard to vertex form, we already know A, it's still going to be the same. We need to find H, and we use the formula H equals negative B over 2A. And then we need to find K. Actually, I think I forgot the A in that H formula, and I think it's because back here, when I recopied this after I erased, I forgot to put in an A. So this was minus 2AH. And then there would have been an A here and an A here. Okay, so that's a little better. Okay, so we find H using that formula, H equals negative B over 2A. Now to find K, I use that formula for C. Oops. Okay, and we usually just solve this for K. Alright, so I would subtract AH squared from both sides and get K equals C minus AH squared. Alright, so there we have it. Here's a second option. It also works if you know the value of H. You can actually substitute that into the quadratic equation in place of x, and if you simplify that, you'll end up with K. So we'll do an example and see how that works as well. Okay, and then if you want to go backwards from vertex to standard form, then we just follow order of operations. So we do the exponent first using FOIL, then multiply by A, and then we add K. Okay, so let's try it out. For the first equation, right, converting to vertex form. So this one is in standard form. So first thing I want to do is identify A, B, and C. So A equals 1/2, B equals 2, and C equals negative 2. Alright, so to convert to vertex form, I want this to look like A times x minus h squared plus K. So I already have A, that's done. I need to find H and K next. So I'm going to use the two formulas. H equals negative B over 2A. And then I'm going to use K equals C minus AH squared. Alright, so starting with H, negative B. Well, B is 2, so that would be minus 2 over 2 times A, and A is 1/2. All right, so we have negative 2 over, and then 2 times a half is 1, and negative 2 over 1 is negative 2. So h is negative 2. And then k is c, that's negative 2, minus a, which is 1/2, times h squared, and h was negative 2. All right. Now make sure you write it like this with the parentheses around h and the parentheses around h and the parentheses around a. It's only the h that's being squared, not the a. If it had been the a, then I would have seen a parentheses around both a and h. Alright, so now when I simplify this using order of operations, I'll do the exponent first, and that applies to only the negative 2. So negative 2 times negative 2 is positive 4. And then 1/2 times 4 is 2. Negative 2 minus 2 is negative 4. So k is negative 4. All right. Now, I mentioned a second way to get k, so let's look at that. We can plug k into the quadratic equation, plug h into the quadratic equation in place of x, and when we work that out using order of operations, we also get k. So let's try that. I'll substitute in negative 2 every place I see an x. All right, negative 2 is the value of h. And then work this out using order of operations. So negative 2 squared is 4. Alright, and then multiply. Half of 4 is 2. 2 times negative 2 is negative 4. And then 2 minus 4 is negative 2. Minus 2 is negative 4. And we get k again. Alright, so you can use whichever of those methods that you like. Alright, so now I need to finish this off and actually write the vertex form. I have everything that I need. So vertex form is f of x equals a, which is 1/2, and then in parentheses x minus h. So now I have x minus a negative 2, and we're going to write that as x plus 2. Alright, and then plus k, I have plus a negative 4. Alright, so my final answer would be 1/2 times x plus 2 squared minus 4. And that's vertex form. Alright, how about converting to standard form? So the second example here is already in vertex form, and I want to go backwards to vertex form. Alright, so I'm going to do this using order of operations. So first thing I need to do is x minus 1/2 times x minus 1/2. So we get x squared for the first term, then the inner terms, negative 1/2 x. Right, outer terms, also negative 1/2 x. And last terms, we have a positive, and then a half times a half is a fourth. So this is x squared. Then minus 1/2, and minus 1/2 is minus 1 x plus 1/4. Alright, then I need to multiply by negative 8 and add 7. Okay, that's the rest of the function. Alright, so distribute the negative 8, so we get negative 8x squared. Negative 8 times negative x is positive 8x, and negative 8 times positive 1/4 is negative 2, and then plus 7. Alright, and then the last thing to do is combine the like terms, so negative 2 plus 7 is positive 5. And there we go. Alright, there's standard form. If you wanted to check this, all we would need to do is go backwards, use those formulas for h and k. Alright, so I can try that. So I know a is negative 8, B is 8, and C is 5. Alright, so to find H, I use the formula H equals negative B over 2A. So in this case, it's negative 8 over 2 times negative 8. And those negative 8's cancel, so that leaves me with 1/2. Alright, and then K is C minus AH squared. Alright, so K is 5 minus A, negative 8, times H, 1/2, squared. Okay, so 1/2 squared is 1/4. 1/4 of negative 8 is negative 2. And 5 minus negative 2 is 5 plus 2, or 7. So I end up with H is 1/2 and K is 7, and that's exactly what I see in the original equation in vertex form. Alright, let's look at just the first one here. The second one, convert to standard form. I just wanted you to see that even though we mostly work with equations that have integers or fractions for these numbers, you can do this with things like minus square root 5. So in this case, you know, you're just going to end up with something a little bit more complicated for C when we switch this back to standard form. But it is still possible. All right, any real numbers at all, we can use these same methods. All right, so let's do one more example. Let's convert to vertex form for the first equation. So first of all, let's identify A, B, and C. A is 5, B is negative 3, and C is 7. All right, next we use the formulas to find H and K. So H is negative B over 2A. Now in this case, B is negative, so we actually have a negative, negative 3, and that's going to be positive. Right? And then 2A is 2 times 5. So this is positive 3 over 10. H is 3/10. Alright, and then K. K is C minus AH squared. Okay, so C is 7 minus A, which is 5. Right, times H squared, 3/10 squared. Okay, so order of operations, do the exponent first. So 3/10 is 3 times 3 over 10 times 10, so that's 9/100. Then 5 times 9/100. I would probably reduce the 5 and the 100. Okay, so divide each by 5, you get 1 and 20. So we end up with 7 minus 9 over 20. Alright, then we need a common denominator, which is 20, so this is going to be 140 over 20 minus 9/20, and that's 131 over 20. Alright, so a little bit uglier, but that still works. Is that fraction in lowest terms? So we do always want everything in lowest terms. Alright, so what goes into 20? Well, prime numbers that go into 20 would just be 2 and 5. Those are the only ones. And those prime numbers don't go into 131 since it's not an even number and it doesn't end in 0 or 5. So any other factors would have to be multiples of, alright, anything else that goes into 20 is going to have to be a multiple of 2's or 5's. So I don't really need to check those since I know that 2 and 5 don't even work to reduce this fraction. Alright, so that is in lowest terms. So basically, if you could say that the numerator and denominator don't share any prime factors, then that's an irreducible fraction. Alright, so I have AH and K, so the last thing I need to do is write this in the correct form. So I need A, which is 5, times x minus h, which is 3/10, okay, squared, plus k. All right, and that's it. Okay, we'll stop there. So in this video we talked about converting back and forth between standard form and vertex form.